break at 3, so maybe we can get some questions in, the generic part before getting into more detailed stuff.
Okay, so I work mostly on the same computer architecture part. I have some questions basically with the interface of the functional emulator and any type of time simulator you can add there. So as far as I understood, the main feedback you provide from the time simulators to the emulator is changes in when the event happens. So my question is, can you change the event themselves? I mean, let's say that, for example, I propose a new memory controller, and in some sense I am changing the order in which the operations are sent to memory.
Okay, so yes and no. There's things to be done, but that exactly no, because what we do here is that suppose you get your model and you say you build your model, your CPU model, and you put it in our system. You put the cache, memory, everything. SimNow is going to behave totally independent from us. So your timing model has to describe the kind of events that it needs. And COTSon is responsible for getting your model that information, translating for SimNow. So SimNow, when SimNow starts executing, it will produce a series of events inside a queue that we parse and we put them all together. And then there's the responsibility of the interleaver to determine when those events get to you. So you're like passive in that sense. But and afterwards, so at specific points in time, which are determined by the sampler, we ask you what IPC did that specific core have, and we try to feed back that information to SimNow so that the next quantum, SimNow takes that into account. The main problem here is that you're totally passive, and you don't have any control on what is being sent to well, the CPU timer doesn't have any control. If you program a timing feedback or a timing predictor, you get into the process of how that information is sent back. Then there's another possibility, which is they've opened us, although we haven't really used it yet, they've opened us the way of hooking ourselves inside the functional memory models of SimNow. So as you saw, SimNow has lots of capabilities and you can hook yourself in many, many different places. So we thought of hooking ourselves there for other reasons. But I think that to answer your question, okay, why do you want to change the order? Because depending on who changes the order, changing the order of two memory operations doesn't have any functional effect. So you wouldn't want to change it inside SimNow. You don't care how SimNow functionally emulates what it emulates. It then gives you that information, and then if you write your timing models in a specific way, or if your cache hierarchy has a specific properties, one of them is going to arrive first and the other one is going to arrive later. So that we do take care into account. But we don't take into account changing the way SimNow behaves, although we have hooks to change some stuff.
So in other words, I think if the effect of what you're proposing is time or power, but it's not behavior change, then it fits what we're doing. If you're trying to assess whether your change in protocol is actually correct or incorrect, in the sense that may create a wrong execution, then in that case you'd have to interact with SimNow. You'd have to write something that actually changes what SimNow writes to memory. Mm-hmm. Right? But if most architects are assuming, at least as far as I know, that what they're proposing does not impact the correctness of the execution. Well, you're assuming that someone will fix it so that it runs, and that what you measure typically is the effect on some of your metrics, time, power, whatever. So that fits very well. If you really want to look at, changes in behavior of your application, behavior meaning, the process firing before or after, or whatever you're doing, or whether you're creating a bug or something, then you have to interact more closely with it, or functional like that.
Would it be the case that you change the behavior, but it is still correct?
No.
Well, the question becomes, why would you need that? In the sense that if you really want to measure time,
do that? We use it for last level cache planning, so it's kind of similar. And as memory controller. I mean, we had a memory controller there. And the only limitation is in the timed model. The timed model, we didn't simulate any reordering at the time of the memory references in the system. But that's only a problem of timed model that you can easily rewrite.
So, and I think we do offer some, talking in the SDK, that we're thinking of doing being able to change in memory operations and being changes things and seeing how the system protects itself. So that can be done, but if you want to change functionality, you better go inside SimNow. Then, of course, if you build a model using SimNow SDK, you may want to incorporate the queues and everything so that you can put a timing model outside and say, okay, I'm building a functional model, and eventually I'm also interested in changing the functionality of this model. But I also want to put timing to that functional model. You could build both things. But it gets more. So if you're only interested in the timing, it's much, much simpler than if you are interested in functionally doing something correct. Because if you do something functionally correct, that means that you have to change the kernel. You have to change Linux or Windows so that it recognizes your device. That's one of the things of running a whole full system simulation, is that you run the whole full system. You cannot magically say, as we've all said, when you run simple scale, you say, oh, a context switch is whatever. You cannot say it here, because a context switch is the operating system coming in and doing stuff and changing things. So once you start messing around with functionality, it gets much, much complicated.
Now, I will say, though, that HP and others have created their own devices and put them in SimNow, okay? So there's many people that have written their own devices, and if you wrote your own device, you can put the hooks in there such that it'll, that some of the, because we're actually modifying it some to make some of the devices time-consuming devices instead of just regular. The only time-consuming device we currently have is the CPU. But other ones, the GPU is going to need to be time-consuming, and there's going to be other ones that may end up having some timing information in the functional, some timing hooks in the functional part of it, but only to allow the time modules to tell us time, okay, or to give us.
But yeah, so I think what we're saying is that you need to draw a distinction of what your goals are. I mean, if you're typically assessing a new architectural technique whose primary effect is making things go faster or slower, then our recommendation is work in the timing domain and make the effect of your application be communicated back to the functional simulator, so then the application will behave as if the time is faster. If you want to model to change the behavior, that can be done, as Teresa was saying, but then you have to be prepared to get much more intimate with things like BIOS,
you have to write
operating systems,
yeah,
and things like that. And that typically, you then multiply your engineering effort by a factor of maybe 20. In a sense, you can hack something up quickly in a week, modeling a new hybrid memory system or whatever. But if you want your open BIOS to boot, pick this up, set the registers, and you have to understand it, that 2 weeks turns into maybe 6 months quickly. So maybe I'm exaggerating, but you actually need to get the things running as opposed to just simulating.
right.
One more question from you.
Okay, now we can take a break and we can leave at 2:30, I guess.
Yes, actually further. SimNow was intended from the start to be used from a GUI or from the same directory that it was installed, so it's not very amenable for batch processing. But they already had, so their engineers already needed to use it as a batch processing tool, so they already had lots of interfaces to do. So we extended some of those and we put tools around them to make them.
We also do all our regression testing with batch tools. Batch.
Okay, so we use the same exact things that they are using. So we prepared a set of different experiments that you could do so that you could see how COTSon basically behaves. So